Dear all, today's topic of discussion is graphs, a graph related to the function. In previous lecture, we discussed function, domain. Now we will discuss graph related to a function. This is a very crucial concept of graphs. In our uh, earlier classes, graphs plays a very important role to describe the sorry to describe these properties of the function uh, graphically. If we have a graphical view of a function, then we can find all the properties related to the function, where a function gets maximum value, where it gets its minimum value. Also, the range of the function is directly related to the graph of a function. You can say that. So, the very crucial thing before graphing of a function is important. Which one? Uh, the domain of a function plays a very important role to plot a graph of a function. In previous classes, we discussed domain of functions related of the function, and now we will move onward uh, to plot a graph. So, in basic classes, uh, graphing somehow is very terrible thing, a very difficult thing. How to plot a graph? So today's today we will solve this thing. So you don't worry about this plotting. First of all, you need to follow these two or three steps. Step one, identify the domain of a function. Okay. When you find the domain, the next step is after this step two. This comes with if. If domain is open interval, then choose any values numerical. Step 3. If domain is restricted, either this one or this one or this one. Say this is A, this B, this A, this B, this A and this B. To the interval where the interval is closed, take that value in the set of interest. Then choose this value A and move towards B by taking some values from this interval. If B is closed, then include this b in your interested values from interval a towards b till b, and b must be included. On the same lines, in the closed interval a to b, if you have closed interval ab, then check the behavior of the function by taking x equal to a and x equal to b and some values in between a and b. Mean to say that if your interval is closed from any end, then the end point must be included in the point of interest. Okay. Then step 4, plot a table of somehow in this thing. Here you have x and here f of x. Plot, take some values, few values from this interval, which one is your interval? Here a.1, a.2, a.3, a.4, and so on. What do you mean by 8.4? Put these values in this function and you will obtain f of a. Put this value x equal to a.1 in this function and you will have f of a.1. Say this is an example. This is theoretical concept. So you will obtain these values. When you obtain these values, just plug these values or plot these values over x-axis and y-axis. Along x-axis, take value of x, take the origin as O, 0, right hand side and positive values 1, 2, 3, 4. You can select your scale as per your requirement. On the left hand side it will be -1, -2, -3. On the upper x-axis or below the x-axis, these values can be 2, 4 as per your requirement, 6, and so on. On the same lines, -2, -4, and so on. This is your x-axis, this is your y-axis. Take the value a, say that a is here and f of a is here. Take horizontal axis, take vertical line where they meet, plot that and plot all these values on this x-axis and y-axis and you will have your graph. Okay, this was the theoretical concept. Now we will move towards some example or exercise question. For example, in exercise 1.1 of Thomas calculus, we have a question f of x 1 plus x squared. Plot this function. In previous lecture, we found the domain of this function as -infinity to +infinity. As per requirement, as we said that if we have open interval in the form of negative and positive, the graph of function is well exhibited if we plot that function on negative end and positive end of this interval. Mean this function, the graph shows the behavior of this function over the whole interval -infinity to +infinity. So in that respect, take some values from negative to positive, whatever. I am taking some values -3, -2, -1, 0, 1, 2, 3, few values from the negative end, few values from positive end, and 0. So put this f of this x in this one. Mean check f at -3. What will be answer? 1 plus -3 square. 1 plus 9, 10. So f of x has value at -3, 10. And f at -2, put -2 in this interval in this function and you will find 1 plus -2 square, it will be 1 plus 4 equal to 5, it will be 5. Plug x equal to -1, it will be 1 plus -1 square, 1 plus 1 equal to 2, and you have this one plus 0 now. 1 plus 0 square, 1, and it will be this one. If you check that this is f at 1 same value, f at 2 same value, f at 3 same value. Now taking scale, you can check that f of x is not getting any negative value, so ignore the negative axis. Say 0, 1, 2, 3, 4, and so on, -1, -2, -3, -4, and so on. So we have 1 to 10, 2, 4, 6, 8, 10, 12, -2. Okay. So plot these values. Okay. When x is -3, x is -3, and y is 10. Mark this one. This point represents -3, 10. When x is -2, y is 5. X is -2, y is 5. Y 5 is here after 4. When x is -1, y is 2. X is -1, y is 2. When x is 0, y is 1. X is 0, y is 1. This one. At 1, it has value 2. At 2, it has value 5. At 3, it has value 10. Now combine these points free end. The arrowhead shows that our domain is continuous and range will be continued. Now see, the minimum value of this f of x is 1, and the maximum value is infinity, 1 to infinity. Now we have to check that infinity is not included in the domain, so infinity will be excluded from the range as well. So see, the one point, this f of x has value 1 at x equals 0, and 0 is the part of this domain. If this point is included in domain, the value obtained from f of x will be included in the range set. So range of this function will be, so to find the range, actually you need the graph of a function. Now we will make some example of that function again. Say that exercise question number 2, we have f of x 1 minus square root of x. The domain of this function, as per previous lecture, is 0 to plus infinity. So our domain is restricted now. Now take the interval of interest, that will be x and f of x. I am taking some values. Those values whose square root I can find easily. Otherwise, you can take any values and use the calculator to find the decimal values of this function. But I am playing some logically, so I am getting x equals 0. You can choose any x. So it's not important to take only some regular intervals, but you can take any x. X equals 0, x1, x4, x9, x16, and so on. So these are enough for plotting this function. So plug this f of x, f of 0, 1 minus square root of 0, it will be 1. F at 1, 0. F at 4, f at 16, 0, minus 1. Oh, 9 was missing. Now, on the same lines, nothing changed. Observe the function, maximum value is 1, so 0, 1, 2, 3, or you can choose instead of 1, 2, 3, instead of this one, just a minute please. X is 0, x minus 1, 2, 0, 0, minus 1, minus 2, minus 3, minus 4, and so on. Right? Now, plot these points. X, when x is 0, f of x is 1. When x is 0, f of x is 1 in this one. When x is 1, f of x is 0, x is 1 here. When x is equal to 4, y is minus 1. X is equal to 4, y is minus 1. When x is 9, 9 is here, and f of x is minus 2. When x is 16, f of x is minus 3. So this is the graph. So this is closed interval, and this one be this one. So if you see that the maximum value is 1 and the minimum value is minus infinity. So minus infinity to 1 will be the range of this function. On the same lines, you can find all the graph of the function of the exercise 1.1. I will now, from now and onwards, I will put these handouts on the YouTube in the comment section. You will find or download these files attached as a document there. So wish you best of luck. If you have any question or queries, please write me.